Discussing the Nvidia earnings call on February 26th. Today's February 27th, so we're discussing the call from yesterday. It is I think it's the Q4 of 2025. They have a few weird fiscal situation there, so let's not get into the weeds there. But it's the year end, and they reported stellar numbers. Everything was just amazing. I'm going to talk about the numbers itself, but I think more importantly with Nvidia is the outlook for the company. And I don't just mean the outlook that they gave on the call, but sort of general what's going on. This is not even on podcast. It's February 27, 2025. This is Krim Delco. For the year, we're down 25%. The market is up 2%. We're outperforming by 27%. So Nvidia's call yesterday, I think, was definitely there's a line going through the call, and that is the following: like, you're doing extremely well right now. Demand is very strong. Margins are very strong. Your products are in demand, but is it sustainable? I think that's the main topic here. I think I tweeted something along the lines of Wall Street to Nvidia. Can this continue? Nvidia to Wall Street. This is just the beginning. So I would say that's the summary. And this being Nvidia, and Jensen, the CEO and founder of Nvidia, in my opinion, has been he's been the shot caller for the last couple of years when it comes to innovation and technology. Why that is the case, I think that's probably worth an episode on its own. But the main reason is clearly that he has the product that is necessary to train all these models to do what they're doing. And I think there's two things I want to point out. One is, why does he think that Nvidia's business prospects are sustainable, that they can continue to grow at the clip that they're growing, which is something around 50% growth? And the reason is three things. It is agentic AI, it is software development, and real-world AI. I want to point out those three things as the main drivers of the Nvidia business, the main drivers of AI, the main drivers of the US economy, and the main drivers of the global economy. And just as a side note, somebody yesterday on X posted that Nvidia reminds him of Cisco. And he meant it, I think, in terms of, they always beat and raise, and that's what Cisco was doing in the 90s. People were kind of taking this as a hint that maybe Nvidia is overvalued like Cisco was, and, quite frankly, it still hasn't recovered from, it still hasn't reached its all-time high. 25 years after it's reached that, sort of $100 a share type of range. So the question then is, why is that true? And I think we can talk about the numbers. That's not so important. I think what matters more is the importance of the Nvidia earnings call for the economy. I used to work I started my career in financial journalism before I went to Wall Street. So I used to cover finance and the Fed and things like that in the 90s. And I can tell you, I was more interested in John Chambers' earnings calls than I was in the Fed minutes, because John Chambers back then, he was the CEO of Cisco, and he was kind of giving the tone of where the internet was going back then. And very similar today, I think, Jensen Huang is the John Chambers of today. His comments, for better or for worse, are setting the tone for where the economy, where AI, where technology is going, because these are all the same things. I think the real growth in the economy, real productivity growth, real innovation, jobs, interesting stuff, however you slice it and dice it, whether you're a aspiring student who is thinking about their career, whether you're an investor, whether you're a middle manager who's thinking of re-educating herself to maybe getting a better job. Anything you do today, I think, is going to hinge on these three words: agentic AI, software, and real-world AI. So let me dissect what I mean by that. Let's start with agentic AI. What does Jensen mean with agentic AI? Well, agentic AI is, think of it this way, like We have AI, which is the ability to, let's say Gen AI in particular, so what started with the ChatGPT revolution in 2022 and now is proliferating throughout the world, generative AI. So you can prompt something, and there is a compressed knowledge in latent space that the model can extract and give you answers. So it's not like a retrieval type system like Google. It literally generates knowledge. And Agentic is the next level, which is it can take that and do stuff for you. It can book a trip for you. It can fill out forms for you. It can onboard employees for you. So all of these things. So Agentic AI is here to stay, and a big push, particularly in the startup community. So in my conversations with startups, I come across many attempts to manage Agentic AI, whether it's building platforms for Agentic AI, whether it's actually building agents, whether it's training agents. Now, what that requires, of course, is a little bit of a different approach of training. So what we're doing now is not necessarily compressing knowledge, like, for example, when was Napoleon born, and when was the war of this, and when was the war of that. It's a different type of intelligence. It is fill out this form. If I want you to fill out this form, well, how do you do that? And how do you deal with the edge cases? So, and particularly also, how do I coordinate tasks? For example, if I want to fill out this form, I first have to fill out that form, and then I can fill out this form. So who coordinates these things? So agentic AI is a pretty complex problem, and it requires a lot of different types of data, which in my opinion is a huge opportunity for Nvidia, because the big strength of Nvidia, according to Jensen, one is that when you have a data center that is training stuff, you have to reconfigure that data center for the different tasks that are at hand, whether it's agentic AI, whether it's software development, whether it's real-world AI, whether it's traditional large language model training, whether it's inference. And you can use the same kind of metal hardware, Blackwell in that sense, and which is the latest version of hardware that NVIDIA is selling. And it's reprogrammable through CUDA. So CUDA is the layer of software. It's sort of the x86 of today. It's the intermediary between the metal and the application. And in particular on the training side, that is very important, because the training is really the software development of today. That brings me to the second thing, which is software. What does Jensen mean with software? Well, with software, this goes back to Andrej Karpathy's Software 2.0, which I think is one of the most important tweets and essays and presentations that I think has been given in Silicon Valley for a decade. Software 2.0 differentiates itself from Software 1.0 in the following way. Software 1.0 is explicitly programmed things that do stuff based on those explicit programs. So what's very important about Software 1.0 is, first, it is sequential. So you do this and you do that. So it's very von Neumann-ish in that sense. For people who are familiar with the von Neumann architecture, it requires an I and O, input-output, and it requires processor, it requires memory. So the traditional computer. What's most important, in my opinion, with Software 1.0 is the following. When you give Software 1.0 a certain input, then it does the same thing. And it always does the same thing. And when you give it a slightly different input, it does a different thing, but it does predictably a different thing. Software 2.0 is the software development, and that's why I mentioned that also in the first instance when I spoke about Agentic AI. Software 2.0 is really software development, and that is the training of AI models is the actual software development. So the AI model is, if you will, the brain, and the training is the data that you feed that model, so it trains itself to do certain things. That is Software 2.0. So we're still in early days for that, but it's important to understand that that is the future, and that the world is going towards that kind of model. So Software 2.0 is in a sense an AI-driven software development. And that brings into place the agentic side of things, because with agentic software 2.0 development, we now have algorithms that define themselves. We have software-defined algorithms, software-defined data centers, software-defined everything. So I think software-defined everything is eating everything, or somebody should come up with something like that, because we can now have agents that write software and other agents that evaluate that software. And there's a very interesting professor at Stanford. Her name is Masrihani. She does self-evaluating systems or something like that, a class, which I think is really, really important, because that's exactly where things are going, right? You have, for example, software, which is prompted. So literally you're saying, I want to have a software that fills out an employee onboarding form. And then you have an agent that actually writes that software and maybe also generates some data to train the particular software to get it a little bit better, or evaluates itself against eval, and then eventually comes up with a solution that is the best it can come up with. So that is sort of the software development side of things, which is very AI driven. The third thing that he mentioned is real world AI. Now that is robotics. I think for frequent listeners on this podcast, it shouldn't be news that we are very focused on robotics, because our largest position at Orange Capital Partners is Tesla, which has the largest real world robotics endeavor going on right now, which is the full self-drive Tesla cars. We also have Optimus, and generally large investments in real-world AI. Real-world AI means a lot of things to a lot of people. So let me try to define what we mean with that, which I think is very analogous with what Nvidia means. And that is, real-world AI is a four-dimensional training problem. So you have three dimensions: space and the time dimension, and you also have a lot more data complexity. For example, just one simple example, how do you tokenize an actuator of a robot arm? Do you use vectors? Do you use the envelope between vectors? So there's a lot of still work to be done in actually learning how to even train robots. It's not clear. We're still in early days. I think Pi Zero, the endeavor by Sergey Levin et al., is a very, very good example of an endeavor that is trying to build sort of the Linux of robotics, sort of an open source based system that standardizes a lot of training and tokenization and those sort of things. Now, what that means for NVIDIA is more training, more data, more flexibility, more necessity for Blackwell. Now, why is Blackwell such a good product? According to Jensen, it's because it does more for less. So when you put this thing in place, which is very expensive and has a high margin for NVIDIA, the customer still wins, because the customer gets more tokens per dollar, more tokens per megawatt, and that is the game right now in terms of AI. Jensen said this in a past earnings call, that AI is the new electricity, in a sense that we're building these massive data centers, or these massive power plants that generate tokens that help us understand the world and build agentic AI software development tools and real-world AI. So having said all of this, now how do we see NVIDIA as a company? Again, we emphasized this in the past. The largest player in AI is NVIDIA, because they deliver something that everybody wants, which is agentic intelligence, which is basically where this is going, agentic intelligence. I'm going to say what I mean with that in a second, but I think I want to emphasize agentic. I think the word agentic is right now being used for a very specific way of AI, but I think in the future, I think AI can be replaced with the word agentic, because that's really what AI actually is going to be, agents. Like just pure intelligence. Take a human person, right? If you're very good at solving a math problem, then that means you're intelligent. Or let's say you have a very high SAT. That's definitely a good thing, and it's an IQ test and all of that. But what you really need as, let's say, an employee or a spouse or whatever, but people are not useful because they're intelligent. They're useful because they're agentic, so they can actually deploy that intelligence for something useful, hopefully purposeful. But fundamentally, before you even start arguing about purpose, they have to have agency. There's a lot of people that don't have that. And a lot of our AI systems today are not. The ultimate agentic system today is the FSD Tesla, because it makes decisions on its own. And I've recently listened to the Gradient Descent podcast. Shout out to the Gradient Descent podcast about agentic system. Links in the show notes. Very, very good podcast. Highly recommended, from people in the field, practitioners, not a lot of academic jargon, real stuff. Very good, very good. So what comes out in that episode is a definition of agentic system, which is something along the lines of it is AI that does things on its own. So it's not prompted all the time to do things. It has a certain purpose. For example, take me to, let's say I'm driving now from Palo Alto to Half Moon Bay, and take me there. That's it. And now the system does everything else itself. It's just turn on the blinker, it's going to turn right, it's going to turn left, it's going to go on ramp on 280, and all of these things. So that's agentic. And we have the same system evolving in other areas, whether it's travel booking, whether it's human resources. And we're going to have it a lot in robotics. Robotics is still in the early days, but again, fundamentally, what all of these things boil down to is more tokens for less dollars, more tokens for less energy. That's where Nvidia has a sweet spot. That's why they're so strong in demand. Now, there's competition, and Wall Street has asked Jensen in many instances how competition is, how we're faring with competition. I think Nvidia has always been very open about this. ASICs are good, competitive chips are good, all these things are good, but the reprogrammability, the flexibility, the scale, and the cost per token are still the best at Nvidia, and that's why they're winning in the marketplace. However, there's one caveat, which is China. Unfortunately, in China, they're not able to grow as much as elsewhere because they're not able to sell their main product lines, their older product lines, and those are competitive with comparable product, and therefore China is very competitive. So to summarize, I think the earnings call of Nvidia has revealed for us, we reiterate our thesis that the risk to Nvidia is to the upside. What we mean by that is that it's much harder to gauge the upside of Nvidia than the downside. The downside is the stock is 130, and let's say it can go down to 40, right? That's kind of where it sits. But it's really, really difficult to gauge whether the stock can go to 200, 400, or 4,000. And yes, you might say, are you crazy? 4,000? Like that would be like trillions and trillions and trillions of market cap. Yeah. But what we're seeing here is an industrial revolution at a scale that humanity has never seen. By definition, every industrial revolution is like that. Agriculture, industrial, computer revolution, and now AI revolution. Cognitively capable agentic systems are going to create what David Deutsch depicts in the beginning of Infinity. They will create agentic, intelligent systems that can solve problems, create new problems, and solve problems. So there is literally an infinite amount of potential here because we can't predict knowledge creation of these systems yet. Maybe right now we can, but at some point they will become like humans, unpredictable in their knowledge creation, unpredictable in their agency, and therefore the ability to create wealth will just get turbocharged. And using David Deutsch's definition of wealth, which is all the possible transformations of a society, well, if you add these cognitive abilities, agentic, software development, real-world AI, by definition, wealth is going to go up. And when wealth goes up, and we use the P and Q model, which is the amount of wealth you create, let's say Nvidia creates 100 units of wealth, and it can, capture maybe 10 units of that, so 90 goes to society. And if that is close to infinity, well, then you can actually get to a $40 trillion market cap or something like that. We're not predicting that right now as we speak, but we're just saying that that is definitely the risk to Nvidia. In terms of numbers in the short term, for people who care about the stock in the short term, we project about 25% growth for this year, and at a 30 times earnings, you are looking at around 30 times earnings. Roughly, that's what we're projecting. So the stock is 130, and we have, we project maybe 450-ish. So something aligned with 30 times earnings, which is certainly not very expensive. Now, those earnings are inflated, and maybe the growth is a little bit shy because right now they're still growing 80%. But that's what the street is projecting, maybe 25, 30% growth. We expect at least 50% growth, and we think that the stock can go back to 50 times earnings. So at least 200 is in the books for this year. Thank you.